Yeah. So, hello everyone. Um, Welcome to FIG 2021 Trimble's Platinum session. Um, Today's session will be on TBC and its role as the nexus between your field data and creating the deliverables that your clients require. And to do that, today we have two of my colleagues who are domain experts who will be delivering a presentation that would establish why TBC needs to be at the epicenter of all your surveying and engineering operations. So I will just introduce the two colleagues. You can see them on the screen. Joe, can you share the slides?
Yep. There we go.
Great. So Joe is Trimble's geospatial office software market manager, but prior to that, he worked in support roles with the Trimble geospatial team. He's got practical professional experience in engineering survey, working on large projects at the O'Hare International Airport, and prior to that on I-65 on a cable stayed bridge. He's been a great engineering professional prior to joining Trimble, and holds a bachelor's degree in civil engineering and a master's degree as well in landscape architecture from the University of Illinois at Urbana-Champaign. So that's Joe. The next presenter is Riley. By the way, Joe Blacker goes by the name Joe. We affectionately call him, so you can always refer to him in the comments as Joe. Riley is also a product marketing manager for Trimble, for our monitoring and tunneling business area. He's a trained surveyor, spent in excess of 8 years on cadastral and construction projects, mainly in North America. And today his focus really within Trimble is developing software that would enable surveyors and civil engineering professionals build the next generation of underground infrastructure. Riley also holds a bachelor's degree from geomatics engineering from the Mecca of Surveying, which is University of New Brunswick. So those are the two presenters, and what we will do today for today's session is both Joe and Riley will present, and the course of their presentation, if you have questions, I would advise that you post them in the Q&A tab, so that at the end of the session, Joe and Riley would take questions. They would address some of those questions, and then they would also point you to additional resources that you can use to continue to develop your TBC skills. So I would hand over now to Joe, so that Joe go ahead with the presentation.
Yes, and can everyone see my screen? Okay, there we go. Thank you. Here's our agenda. First off, thank you very much for having us, and I hope you enjoy the session. If there's something that both Riley and I like talking about more than TBC, I haven't found it yet. So we're both very passionate about this topic, and hopefully that comes through in this presentation. So we'll talk about the changing or the ever increasingly complicated needs of today's surveyor, and how TBC can bring those tools in your survey toolbox together. And then we'll really dive into some really specific examples with cadastral workflows, as well as engineering workflows, where Riley will showcase some great progress within Trimble Business Center for monitoring and tunneling. And then, like William said, at the end, if or when there's time, we'll have questions, and then next steps, some additional resources. I believe this deck will be shared, so there's like hyperlinks and things in here that you can have access to. You don't have to be scribbling any links down or worry about broken links or anything. So with that, meeting the needs of today's surveyor. So how TBC and how we position TBC in this broader landscape of land surveying. So there we, you, he, she is the surveyor today. And some of these tools, kind of the quote traditional sensors, as well as the ever increasingly common terrestrial scanners. We work for Trimble, so I'm going to use Trimble hardware units here as an example, but things like GNSS, things like optical instruments, the SX10, SX12 has really been a revolutionary sensor for Trimble, as well as some of the new terrestrial scanners that Trimble has, as well as third parties have out there, and then digital leveling as well. Can never forget about our old friend, the Trimble Dini digital level. But that's just the start, right? Additional sensors that are becoming increasingly common are aerial photogrammetry, either fixed wings or rotors, manned or unmanned solutions, as well as mobile mapping systems. I've got the MX9 shown there from Trimble. But then we go on, right? There's been an ever-increasing push to get the surveyor involved in the BIM conversation, right? With the 3D BIM or geospatial BIM kind of conversation, where things like metadata and attributions and a third dimension are becoming ever more important in the surveyor's world. And speaking of attributions and features, the GIS world as well, right? Things and connections with industry leaders and partners there are, again, becoming ever increasing with the surveyor here, the data that the surveyor is collecting at the center of it. And then we would be remiss without mentioning, if we didn't mention, cloud services. So both cloud-based processing or data transfer or applications, things that help you, not just cloud for cloud's sake, but productivity enabling tools that are hosted or available via the web. And then from the surveyor, from taking all of this data, moving out to a CAD environment where they can take this data, process the data, post-process the data, and then deliver whatever type of final result that is needed for the project or for the client. So this world is increasingly large and expanding. I've probably missed some things here, but the surveyor is at the center of it. And as you may have guessed, that's where we're trying to position Trimble Business Center, TBC, to handle all of this type of data, to be the one single environment to do all of these multitude of applications that surveyors are doing today. And I'll say that's a fun and entertaining challenge, and we will go into a little bit more of how we do that right now. All right, so our high level statement is what Trimble Business Center is. We're trying and we're striving to be the complete survey and construction office software, enabling field to finish workflows with confidence. That's a mouthful, so let's break that down a little bit further with some practical examples. So leading workflows, leading field to finish workflows in Trimble Business Center start off with the field data. And that's one of the really unique pieces of Trimble Business Center is you're working with the raw data from your field sensor. So whether that's a Trimble sensor, hooray, great, we love that, or a third-party sensor, which is the realistic, and there's a lot of great products on the market as well. We're trying to support the raw data. So you're working with the observations, with the vectors, with the GNSS observations, rather than just, XYZ or YXZ point files. There's really no information behind it other than a three-dimensional coordinate. So I love this screenshot, and there's been a couple out there that we've had where it really shows this dynamic nature of, all right, we're leveraging vectors. Those green lines are optical vectors from an optical instrument. We're leveraging point clouds. We're leveraging imagery taken from the scanner sensor itself, all in one environment, and you can interact with that data. And then what Trimble Business Center is probably known for the most, rightfully so, is our leading adjustment packages. That's baseline processing, network adjustment, COGO routines. So things that really will take your field data and improve it, reduce it, adjust it so you're getting the most precise and the most accurate measurements out of your field sensors as you possibly can. And then CAD and drafting, a space that's near and dear to my heart. If you haven't been in Trimble Business Center in a while, take a new look. We've added productivity enhancing tools such as the CAD command line using industry standard shortcuts to really improve the ability to represent 2D and 3D geometry in a much more efficient way, alongside with any industry standard packages as well. Surfaces and volumes. So being able to compute a digital surface, both either 2.5D or a projected surface to pick up some vertical surfaces, or a tunnel surface where it kind of folds over itself, right? A full 3D surface mesh. And then being able to compute hyper accurate volumes from that data is definitely a core functionality of Trimble Business Center. And then the corridors, for my money, this isn't a design package, however, but it's a field data prep and modeling package to take a corridor design and model it. And for my money, it's the lowest barrier to entry for some very, very powerful tools and representations to model anything from a local road to a collector road to a highway or intra-country motorway. So really, really powerful parametric design-based tools focused in Trimble Business Center. Data prep. So on the construction side, almost flipping the message around. So really from finish to field then, where you're taking a PDF plan set or an existing model, prepping it for a machine, for some grade control systems, for example. That's also a staple of Trimble Business Center. And then sticking with that construction theme, quantity takeoffs and mass hauls. So anything that can be tabulated or summarized to move, all right, I've got a site plan here. How much dirt do I need to move from point A to point B to clear that site away? That's very, very much a staple in Trimble Business Center. And then Riley and I have been doing this long enough. We probably need to expand the specialty solutions because they've gotten much more robust. But point clouds, right? We'd probably make an argument that point clouds aren't specialty anymore. Tunneling, utility modeling, aerial photogrammetry, anything, again, those kind of vertical applications that a surveyor doing, that all exists in this one environment that can all coexist with any sort of other traditional, quote unquote, survey sensor as well. So that paints the picture of TBC and what we mean about field to finish workflows in a kind of a presentation neat form. All right, so how do we do this? And some kind of unique features of Trimble Business Center. And our pillars have always been confidence, data integration, rich deliverables, and interoperability. So confidence when your reputation is everything, right? You can stand behind your work. Data integration, talked about that a lot already, where all types of geospatial data can come in one environment. Rich deliverables, what is your client? What is the project expecting? What do you need to deliver? And then interoperability, connecting with industry standards, industry leading partners, the Autodesks, the Bentleys, the Esris of the world as well. I want to talk a little bit more about each one of those four here real quick. So confidence, I'm not going to read. There's a lot of text on these slides, but it's important to paint this full picture. So traceability, right? There's benefits to having your field data rather than just simple exports, simple CSVs or text files of just point lists. So we are surveyors too, as William introduced. The platform is developed and managed worldwide by a team of surveyors. We have strong presence in the United States and across Europe, as well as in Japan and Australia, New Zealand, and other places. So we really are a worldwide product and platform. The Trimble name is synonymous with surveying, right? And this is our data hub for geospatial data. So we have a trusted pedigree from the old GP survey to Geomatics Office, TGO, Terra Model on the construction side. All of those products have led and built our history and our knowledge base up into what TBC is today. Then on the data integration side, so industry-leading adjustments on the traditional, again, quote unquote, traditional sensors. Some highlights here, leading team on coordinate systems and how dynamic datums have now been emerging. I believe there's an FIG session that some colleagues are doing on the work that Trimble is doing to assure you that we're supporting the geodetic datums that are needed and that are being transformed here across the world as we add a time element, as plate tectonics come more and more into developing these datums. Move on. And then kind of this newer frontier, right, with imagery and scanning integrated with your traditional sensors. So being able to see what the instrument sees with what we call Trimble Vision and station-based views really puts you inside of the instrument to capture all of the data or to view all the data on the project. Some of our latest advancements is a technology we call ECOG AI with feature extraction. So taking point cloud data and turning that into actionable information, whether it's point-based, line-based. We've also added cross-section in our latest release, cross-section extraction from point cloud. So to be able to do more with this data and a lot more virtual surveying, right? That's becoming more and more common and useful in these environments today. And the other nice thing about the last point here is data in TBC. So point cloud tools are data agnostic, for example. So you can take an aerial photogrammetry point cloud and run feature extraction on it or run point cloud classification on it, just the same as you can do with a terrestrial or a mobile scanner as well. And then speaking of some of those verticals, so there are modules and features of Trimble Business Center that cover specific needs. And Riley will talk a little bit about that. But this ability to scale in one platform. So as you or as our distribution partners work with our customers to expand their businesses or pursue a new line of work, they don't have to learn a new software or purchase a new software because TBC can support it, and across mobile mapping or tunneling or aerial photogrammetry, you're still just need to be in the one place. All right, coming through here, rich deliverables. So this is a nice long list of everything that we've developed over the years and are included. The pieces that I want to highlight here that I haven't quite touched on is, all right, what are you going to do from TBC to connect your data out to other platforms? Seamless publishing into Trimble Clarity, which is our online geospatial data viewer for point clouds or traditional data. All that vector data and everything goes into Clarity as well. Or augmented reality, Insight Vision, right? To be able to see the site, see the construction, see the subdivision on site ahead of its built in real time is something that TBC can connect to as well. And speaking of connections, again, Trimble branded or not, your data, we want you to work with your data in TBC. And if you need to connect to other platforms, again, I'll use the big three as the example: Autodesk, Esri, and Bentley. We want to enable a seamless and rich connection, reducing fidelity loss between transferring data between these different packages. So those are our pillars, and I'm doing really, really well. If any questions have come in on that, we can take them now. Otherwise, I'll keep going. I think we're good.
I think you're okay for now. Yeah.
Thanks, Riley. Okay, so this all sounds great, right? Let's actually go in and show you what we're talking about here. And one of the examples is a cadastral workflow. So, from collecting data to do something like a boundary survey or a plata survey, to creating parcels, maybe a legal description, being able to label and create a nice plan set for that is something that I'm going to showcase and talk about now. I can advance the slide. There we go. All right, so field definition one software, how we do that. All right, let's take our raw data, right? Wow, what a mess, right? Green TBC is optical. Those blue, those longer lines are long baselines to the nearest base stations. So you take your data, you bring it into TBC, it looks something like this. The next step then is to adjust and reduce the field data. I love putting in screenshots of spreadsheets because everybody loves seeing them. You're not supposed to be able to read it. It's not supposed to be fun or exciting, but sometimes this is what you need, right? This is all of that metadata, all of the attributions, all of the observation data that was shown on that previous screen, right? And this is where in TBC, you can adjust things like rod heights, or prism constants, right? If you went through all day, and I know I've done this, and fat fingered something in, made a mistake with a constant or a height or something, you don't need to go back out and redo all of your work inside of TBC. You can look at something as exciting as this spreadsheet and change it on the fly. And all of your all of the data and everything updates. If you blew an instrument height even, you change that instrument height, all of the measurements from that station get automatically updated, and you just saved significant amount of rework, travel time, maybe a little embarrassment. I know I've been embarrassed before by by field blunders, but you can definitely save some time. Do your baseline processing, right? Do your least squares network adjustment. Get that data. Get that control network tight. Get that boundary. Those boundary lines as tight and as accurate as possible. And then a very powerful workflow is feature coding, right? So if you feature coded in the field, you could have automatically line work be generated for you. So we went from that mess of observations and occupations to something like this with a couple clicks of a button, right? If they were coded in the field, you process against a feature code library, and you get different line styles, you get different object types. You can see there's lines, there's rectangles, different labels, different colors. All can be done and set up with a well-defined feature code library. That can also be done in the field as well, in the likes of like a Trimble Access. Feature coding can be done to help you see and visualize more of what you're doing in real time out in the field. All right, and then creating parcels and with coordinate geometry routines, COGO routines. So to get something like this, you can check for misclosures, right? Really, really important to see how and if the boundaries were collected properly. In some jurisdictions, they like to have a description, a legal description of the plat of land. There's a template in TBC and an editor to set up things, to use your data and put text to it so that you can write a legal description to then go and throw on a plan set either digitally or print, like I have shown here. So all of this project was done. This was a real project. This is a highlight from a Power Hour session that we did a few years back with a surveyor in the southeastern United States. The project from field to finish was done with Trimble hardware, and then all staying inside of Trimble Business Center. So benefits here, and again, I'm gonna hammer these home because this is where we believe in and we work for every day in Trimble and the Trimble Business Center team. Field to finish benefits. So working with the raw data, not just exported points. You as a user, new user or current user, I can tell you right now, there's not one person on this planet that knows everything about TBC, but there's less onboarding time if you just have to learn the one software, right? For surveyors, for construction professionals, that's what we're striving for, so that you can just learn one software, keep up with our biannual major releases and new features and enhancements that we're always working on, which then it will lower your costs, less training, lower costs to maintain your licenses. And you get benefits out of this too with one software, data integrity, right? No loss of fidelity or metadata moving from package A to package B to package C, back to package A to package C again. And then flexibility, that scalability that I talked about for additional workflows. You'll see here the tunneling workflows and the things that are supported there have expanded exponentially over the last few years. And it's all in the same environment. Nothing has changed. You don't have to buy a new package to get all these nice new tunneling features that Riley will highlight here in a little bit. And then support for Trimble and third-party hardware is really important as well. We really want to be this data hub. So I think I will take my sales pitch hat off and we can get more into the software now. I've got some videos and linked here. These are linked to our YouTube TBC survey channel, as well as we've run a very, very successful Power Hour webinar series. So every month we take a workflow, and these are free. It's usually the last Wednesday of every month, and in Europe time it would be in like the afternoon, 4 or 5 o'clock, 4 or 5 p.m., 1700. And bring in somebody from the industry or from Trimble, and they'll explain an entire workflow. We've got one exactly on cadastral. I was told we don't have enough time to showcase the whole, I think it's an hour and 13-minute video. So I went scouring for some video demos, and I found this central one here, parcel creation and map check. It's about 7 minutes long. I'm actually doing quite well on time, which is a rarity for me. So I can go ahead and try to play it here to really get you a feel of what that experience, that cadastral survey, boundary survey experience is like inside of TBC. So let me know if you can hear the audio once it starts.
So if I want to replicate this
audio is good.
Great. Thank you, Riley.
Layer on. These purple lines, we have the subdivision already created. This was done with the create Kogo command. There's a great YouTube video. Check out the link that should be on your screen now to see the YouTube video on how this command works. But we've added a few new things to it in TBC version 4.10, and those features are included in later versions of TBC. Basically, it's a command line type input where you can type in with abbreviations and directions. So here we have starting coordinate 10,000, 10,000, and then we go through, and so LX is line extend, and we have the distance that each one of these lines extends. When you click in the command box here, it highlights the line segment that command is related to on your subdivision. So the idea with this is, with your hands never leaving the keyboard, you can input an entire plan very quickly and easily. So now here on the map check tab of Create Kogo, we can do a few things here. The first thing I'll do is here on maximum disclosure, I'm going to make this something small, say 5 thousandths, to demonstrate what happens when we aren't meeting our maximum disclosure. If there's Create Kogo line work in your project, you do not need to select it. You can just hit Create. We have 14 parcels that failed due to too much misclosure. And the parcels that we can see are the ones that worked. So I'll put this back up to what it was, 0.328 of a foot. My project is in US survey feet. So I'll go and create the new parcels, and there we have them. In some municipalities, you're required to have a separate parcel for the roadway. Let's say in this case we don't, so I can just click on the roadway parcel and hit remove, and it'll take the roadway parcel out. Here we have two flags. Let's check out what those are for. 23, parcel 23. The precision of 12,995 is below the threshold of 15,000. For this project, that's okay. So I'm going to go and reduce my precision required. So up here in the project settings, we can do computations, COGO, minimum precision. Let's set this to 12,500. Down here, we get a nice definition of what minimum precision is. Precision is the ratio of the parcel's perimeter distance divided by the sum of the misclosures. Parcels with precisions less than this threshold will be flagged. Perfect. So that's taken care of. Close our flags pane. If we zoom in here, we can see that the subdivision plan has this parcel labeled as 9066, and we go around increasing sequentially. So in order to easily renumber our parcels, in order to match what we have in the plan, we come down here for parcel name, and we can do 9066, and then we can go through and renumber each of our parcels so that it lines up with what is on the subdivision plan. Consistency is a lovely thing. There we go. All of our parcels match up with what is on our subdivision plan. All right, so now into the label parcels. When we come in here to label parcels, automatically all of our parcels are selected. I'm not going to worry about that. I'm going to hit the backspace key inside the multi-select lines to label. And I'm just going to select that one that I mentioned earlier, parcel 9076. So let's go ahead and label that parcel. Here we have our labels pop up. We have a bearing and a distance for each of our outside segments. And we have a bearing, or a chord bearing, a arc length, and a radius of arc for our arc length. So now let's close out of here, and we will jump back out here, and we will pull up a map check report. The map check report calculates the misclosure for each of the parcels that you have selected when the map check report is generated. So here we have all our typical report information, our project file and our coordinate system. And then we have our project or our local site settings. And then we get our traverse length and our total misclosure, which is what is used to generate or calculate our precision ratio. The precision ratio is the traverse length divided by the total misclosure. And we have our scale factor, the size of the parcel, where it came from. And then we have, for our misclosure, there are two sources of misclosure on this parcel. So we have a northing and easting for each of them. The bearing from one endpoint to another endpoint for our misclosure. And then we have the magnitude of it, the distance, and then the latitude and departure of each of those misclosures. And here on our next page, so here we have the individual line segments that make up parcel 9076. We have an arc, a line, some misclosure, line, line, misclosure, line, line. We have the northern easting of the start of each of those sections, as well as, you can read here, the liner chord bearing and the liner arc length, as well as the arc radius for the arcs. On our next page, we have our labeling precision misclosure, We have another video that goes over what this is. Check out the link down there in the corner to go watch that video. And here we have a nice chart that shows our parcel 9076. We have our point numbers labeled. We have our bearings and lengths for each of the chords along the outside. And we have the information for our arc on here. Back to the plan view. So there's how hard it was to make one of our parcels. If we now remove that labeling, we can add the labeling for all of our parcels and create a similar report that goes through every single one of these parcels.
All right. Presentation. I'm pleasantly surprised that
I
audio
want to replicate
worked.
this subdivision,
We'll pause it.
as I've already
Sorry.
done. Let me turn the layer on.
Oh, something's got to go wrong, of
We
course.
have the subdivision already created. This was done with the create code command.
Okay. Let's see if I just advance the slide. There we go. So that video really showcased, get the other one playing now too. That video showcased just a snapshot of what Trimble Business Center can do for you for the cadastral. We showed the line work and everything kind of already created and drafted. That could be collected from the field. That could be from an existing plat of survey. That could be from really any source. So that routine really showed you how you can take existing data or collected data and then move into the parcel creation routine, boundary surveying, all within, again, one platform, Trimble Business Center. These additional resources are great. We've done a lot of nice things with feature coding and managing feature codes directly inside of Trimble Business Center. That's what the presentation on the left is, and then the one on the right is the cadastral power hour that I took the example from in the previous slide. Okay, so from here, I will pass off to Riley, and I will stop sharing, and Riley will take over the screen share.
All right, thank you, Joe. Just a quick check that let me know when you can see my screen.
Yes. Okay.
Excellent. Thank you. Hello, everyone. So we've got into the core of TBC, but now we're going to start to focus on what I like to call it more engineering survey workflows, specifically talking about more on the monitoring and tunneling side. So it'll be two sections. We'll start with the monitoring and then get into tunneling. Here we go. So monitoring. For those of you who are unfamiliar with monitoring, when I say the word monitoring, we're talking about typically typically movement or deformation of an object and how we measure that over time, typically to support construction, to support risk mitigation, and so forth, as well as safety. And what we've done with Trimble Business Center specifically is built unique workflows that support surveying and construction professionals for those monitoring projects. It's very, very common that surveyors have these project requirements to collect data on a repetitive basis and determine displacements and movement information to provide clients with that. And we want to ensure that we're removing any pain points in those workflows using both from the field and the office perspective. So a little background on Trimble's history with monitoring. We've been in the space of deformation monitoring for quite some time, particularly in the vein of automating the process. And when I say automating, I mean automating the things that are repetitive for a surveyor or a monitoring professional, which is typically the data collection, the processing, and the general data management. And so how we do that is through the integration of all geospatial and geotechnical sensors that may be on a project site, like total station and GNSS being more geospatial, and geotechnical things like tilt meters, crack meters, laser extensometers, and having that data all centralized and automating that process, so you're able to, as a monitoring professional, have that confidence that your data is being collected properly, and as well focus on the important things, which are the deliverables, the alarming, the reporting, and working with the stakeholders. So when we talk about monitoring, there's typically on the spectrum of project requirements, there's typically two types of monitoring applications, if you will. So you have on the left side more of your manual based. This is kind of what I would call traditional monitoring, where you have more multiple visits to site. You're typically, whether it's once a month, once a week, once a year, you're going to site and you're measuring the same set of points. You're collecting all that data. Your sensor isn't fixed on site, so you're taking your total station or your level or whatever it might be back with you home or to the office every day. And you're typically looking for slow, imperceptible movements. You're not looking for safety of life hazards, because you would be on site all the time, and you're typically not storing or collecting huge amounts of data. It can be a fair size, but it's usually not gigabytes of data. Now, as you get more and more, or the project requirements grow more and more, this is where we get into more automated monitoring, where the sensor typically lives on site. It's installed permanently or semi-permanently, and because it's installed on site, we can get data in a real-time or near real-time fashion to some central database and create these real-time alarms and reports. And this is especially useful for projects with time-sensitive movement, where maybe it's a construction project and in the nearby infrastructure can be can move due to that construction project, and we want to know immediately when any movement occurs so we can mitigate those risks as soon as possible. And usually we're collecting large amounts of data over time, and those are stored on some physical server on site or maybe on a virtual server like in the cloud. Now, what we're going to talk today about is this kind of middle ground where we're taking that manual process that was typically performed and trying to automate the pieces that make our lives easier, both in the field, in the data collection side, as well as on the reporting side, which will focus more of our time there today with the vein of Trimble Business Center. So just looking at some applications, when you would typically perform these more manual campaign-based monitoring scenarios. So on the left side, you have your more short-term construction. This is where you might be on site, let's say for 8 hours, and you're collecting repetitive measurements through that whole 8-hour period of time at a high frequency, maybe every 5 minutes, every hour. And it's typically to support the construction process. Maybe you're installing a big pile and you need to know, as that pile is being installed, is the ground or the structures near it moving just during the installation. And typically it's not cost effective to install a whole automated system to do this, because you might only need it for 1 or 2 days. Now, as we move on, now we're looking more at long-term trends with typical low risks of safety. Maybe you're looking at seasonal movement in a structure like a dam, hydro dam, and you may be measuring every season, maybe quarterly, and looking at those movements. And then further on into the next category is more about control and networks. So where you may need to continuously update or check a geodetic or a survey control network. And so all of these, what they have in common is repeated measurements to the same locations, storing that and processing that data and creating reports that typically show movement or maybe lack of movement in those objects. So how does that workflow look, and what's the ideal workflow really? Well, you have the data collection side, whether that's with GNSS, total station, level, maybe it's handwritten coordinate measurements or raw measurements that you've collected with a theodolite or something like that, and usually some field software like Trimble Access to support the data collection and remove some of those unnecessary steps or repetitive steps or automate them. And then there's obviously an element of data transfer where we take the data, whether it's a manual transfer like a USB, or maybe more of a unique transfer like through a cloud platform like Trimble Sync Manager. And then we get into the office where I think a lot of time today is spent on the monitoring process, where we're taking all of that field data, we're crunching the numbers, we're processing it, and we're trying to report on it. And a lot of times this has been done in spreadsheets and even hand calculations, and it can be a lot of time for the office technician. And so with Trimble Business Center, which we're going to spend a lot of our time talking about today, we've introduced a monitoring module that removes the manual data management and processing, but also creates those deliverables, those reports, those charts that you need for displacements automatically, so you don't have to worry about that, and you're removing all of that time you would normally take to create all of that. So let's look a little bit more about TBC, and then we'll show some little demos and videos of how that looks in the software. But why TBC is important for monitoring? Well, like I mentioned, we're trying to automate, not fully automate, but automate the things that will really remove the pain points for us when we're doing these monitoring projects. So my whole thing about this is trying to remove the need for those cumbersome spreadsheets and those folders full of all the data that you've collected in the field, trying to mitigate the need to do that and have it more automated in a sense. So one way we're doing that is all of the data that you monitor in the field, you bring that into TBC, and you can visualize and quantify movement patterns. So you can actually see, is there trends on site, or do we have a shift, a rotation, or a translation in actual movement on site, or is there a distinctive trend? Then we can flag anything that has significant movement. So as I'm bringing data in, maybe I'm measuring once a week a data set, and as I bring it into TBC, I can immediately get flags, warnings saying, okay, this point has moved out of the tolerance. Now we need to dive in and figure out what we need to do to assess that. And then, of course, what a lot of the time we're looking for is the deliverable piece, where we're trying to generate some type of chart or displacement report to, one, quantify those movements, and one, have a report that shows all of that over time, and it's typically a requirement on a lot of these projects for the stakeholders. So all of these things can now be done in TBC. And what's really important there is TBC has already been, as Joe was talking about, it's been the database, the core for all of that geospatial data. Now we're just taking that data and creating monitoring deliverables from it, which in a lot of cases people were already doing that. Surveyors are already doing these things, but we're trying to remove the pain points and make it a lot easier to create those things. So let's show some videos here on how that looks. So this is more in the field side of things, these first two videos. All right, I think I'm back. Lost audio for a second. Thanks, Joe. Yeah, so what we're seeing here is the field software. You didn't miss too much if you're watching on screen. Essentially, I'll play this again. What we're seeing in the field, how to somewhat automate that collection, is a lot of the time we're performing repetitive measurements. Maybe we're performing multiple sets, multiple rounds on targets. And we don't want to manually do that because it's a lot of time for the operator, and it's prone to making mistakes, whether it's a pointing mistake or something else. And so we can automate that function in the field software. And while we're collecting that data, we can get real-time information on the displacements and see if there's any significant movement. Now, just to visualize how that looks, here's a video, and I'll speed it up for time's sake, just to show. So there's no operator, nobody's doing anything. Once I've said, okay, I want to monitor these targets, the instrument collects the data without any further input. So we're removing that need to actually stand at the instrument, constantly turn those angles to every different target. So this is very important where I may be collecting 50 or 100 targets from one setup. This is saving a ton of time while I'm in the field to collect that data. Now, once we've collected all that data, obviously we need some mechanism for visualizing the displacements and so forth. So we can, while in the field on the data collector, we can go in and we can query down into each individual set, each individual round of measurement, and see What was the displacement? So in this case, I'm not seeing significant amount of displacement, maybe a few millimeters here and there on each target, but I can drill down into that and see any trends while I'm in the field before I even leave and go back to the office. Now, where TBC comes in and is really the key part here is about creating the deliverables. So we can take all of that data, we can create our displacement reports, we can visualize any of the alarms that may have been tripped. So if I've exceeded my movement thresholds and I need to verify, okay, that these points were out of the threshold and they're moving a certain direction. Maybe they're settling. Maybe there's some movement downward. I can see all that from a variety of different views, whether it's a table view, in charts, reports, scatter plots, really a comprehensive view of movement on site. And then I can take that data, and in TBC, I can also visualize the movement patterns. So for instance, if I'm looking at, I have a set of points on a building, as you can see here, and I want to know, okay, how is that building or buildings moving? Are they moving up and down? Are they maybe shifting side to side? I can actually visualize that using these vectors, as you can see, the green and yellow arrows. I can visualize that movement. So in this case, we're getting a lot of movement upwards and maybe some movement to the south as well. And that can tell us some information on what may be causing that movement. All right, so we've talked a lot about monitoring. Now I'd like to take the next set of time to get into tunneling, another passion of mine, and I would also say underground mining as well. They have a lot of similarities for surveying. So essentially taking those core survey techniques and technology and applying it into an underground environment where we're GNSS derived. We typically only use optical instruments. And so history of Trimble there is we're taking the geospatial sensors and technology that you all know Trimble for, but we're applying it with unique workflows to the underground environment for underground survey and construction professionals. So they obviously have some different workflows, different reporting and deliverable needs than you might need on a different type of construction, or like for building or earthworks construction. And so we've built unique workflows in both the field and the office software to support that. So we're going to get into more, especially on the TBC side, how that looks. So a little more information. So Trimble's been used for tunneling in a variety of ways all across the world, and in different ways as well. Everything from more of the what I would call project conceptual design phase, where we're gathering the initial control data and topographic information to help assist the design engineers, all the way to more inspection and construction, as well as rail and tunnel clearance inspection for tunnels as well. And how we do that is we look at it more from a life cycle for the tunnel. So it's not just we build a tunnel and it's done. There's all sorts of aspects within that project that surveyors and construction professionals need geospatial data collection and processing, whether it's from the very start all the way through to construction, even helping guide the machinery with positioning sensors, to monitoring, to reporting, and then finally, once the tunnel's built, how do we collect the necessary geospatial data to support inspection and maintenance processes? When do we need to collect assets, and how do we collect those assets within the tunnel infrastructure, leveraging things like scanning and optical technology? So what are we doing with TBC here? Joe alluded to it, but let's dive a little bit more into it. So we have a great module within TBC called the tunneling module. And I'm going to leverage that whole field to finish concept, but apply it to tunnel survey and construction, right? And this is, I would almost call it field to finish, field to office to finish kind of workflow, where it's a very iterative process. It's not collect data, go to the office process and done. It's a very back and forth, because the construction process is not a one and done. It's a continuous process throughout the tunnel until it's built. And so it's really important that, one, looking at how we prep the data and prepare it for the field crews is as automated as possible. And we can bring in design information from other packages, but also take all of the existing tools in TBC and create the tunnel design information and prepare it so we can use that when we go out in the field to do the stakeout, do the as-built collection, and so forth. And not only just the ability to do that, but make it as fast and as automated as possible so that you can get in, get it done, and get it out to the field crews so they can start doing the construction work, which is really, really the important part of this. Now, in terms of actual survey data collection, this is all about productivity. Tunnel construction projects are very, very fast paced, and any delay in that operation can be very costly, but it also can be a very safety conscious process, especially when we look at drill and blast and traditional tunnels where we need that survey data to support things like the foundation, the shotcrete, and the drilling and blasting. And so being as productive as possible by automating the office processing of that data is what we're trying to do in TBC, and I'll show that in some videos here soon. And then reporting. Once again, everybody really cares about reports, deliverables that we can get from the survey data, whether it's a as-built report showing the over and under break values after drilling and blasting has been done, or maybe it's a report showing the position of the TBM rings once they've been placed in the tunnel. We support all of those different types of reporting and making them as customizable and configurable as possible so you can adjust them as needed for the project specifications. And then, of course, being one system, we want everything to transfer seamlessly between the office and the field. So whether I'm scanning or I'm using a total station or a level in the field, I want all that information to come into TBC, and vice versa. If I'm creating any of that design information in TBC, I want it to go back to the field so the crews can benefit from it. So in thinking about that, we'll kind of go through with little videos to support how this looks in TBC and how you can do this tunnel workflow, starting from more of the design phase, and then we'll get into construction and reporting and what you can all do at TBC. So starting with more of the design, you can be as simple of a tunnel or as complex of a tunnel as you want in TBC. Here's a good example of a fairly complex one, but there's no limit on your geometry. It's a matter of your project requirements. All the tools are there for you, and you can create those tunnels in TBC. Whether it's from an imported CAD design, maybe you have an existing one, or maybe you're keying in that information from a plan or a blueprint, and you can do that. And what I think is really powerful is there's multiple ways to visualize and check that design information. So one can be a cross section, but also, as you can see in the top side of this video, it can be viewed in three dimensions as well, so we can see it kind of as a whole design as opposed to just singularly in a 2D view. Now, once we start getting into more of the construction and we think about traditional tunnel construction where we're doing more drill and blast or more excavation type activities, a big effort for surveyors is collecting Sorry, everyone. I'm not sure my audio keeps cutting out. Apologize. All right. So the as-built and excavation reporting. So a big activity is reporting on the construction activities and ensuring that the proper amount of excavation has been performed, and there's no what we call underbreak or undercut, so that it's meeting the design requirements. And so a big task here is being able to take that as-built data and create the necessary reports to visualize that information and quantify it as well. We want to know the volumes, we want to know all the areas and so forth, and we want to know that relative to the tunnel. So as we can see here, we can see the context of the design relative to all of that as-built data that's been collected, and gives us more visual interpretation of the construction activities. And then from there, we can generate all of those as-built reports that show everything from volumes to cross-section views to specific points that the construction crews need to do more work on, for instance, when there's undercut areas. Here, I'll show a little video that shows this. And of course, so here we have a 3D design, and we've gone out and we've collected some as-built data in the tunnel, and we want to generate a report. And it's as simple as a few button clicks, and boom, you've got a nice a report in Microsoft Word that gives you all of that information. Whether you need that to support the construction crews or it's a deliverable to the client, you can provide that to them. Now, when we look at more TBM style surveys, one of the big activities for survey crews is checking the position of the built rings. And you can see those rings quite clearly here in the image. And getting the as-built position of that finished tunnel, because everything that goes in the tunnel afterwards, whether it's a rail track or some other type of what I call tunnel furniture, you need to have that as-built position so you can help the design crew prep that information so they know where the tunnel is actually built. And one of the big new technologies that's been used more and more in tunneling over the past 5-10 years is 3D laser scanning, where you're bringing massive amounts of data in, and creating these reports from it. Now, one of the challenges with that is because you have so much data, you get a lot of noise. You get things like the ductwork, people, machinery, rail, whatever it might be, things that are not the tunnel structure, which is what you're really looking for to check. So we've built tools in TBC to remove this, as being, since it's such a big pain point, to automatically remove as much of that noise or parasitic data, if you will, from the cloud. So you can see here, we just ripped out all of that data. Everything in blue is the tunnel surface, if you will, and then everything else is what we consider noise. So what that's doing is it's reducing that whole chunk of time that traditionally somebody would have spent manually removing all of that noise and then creating a report. It's click a button and then generate your report. So vastly saving time. And then you can get that end report. So for a TBM, it's especially important to get those ring as-built reports and those best fit centerline. Now, shifting gears back to more traditional construction, maybe we're applying shotcrete and we need to check layer thickness. Very important to do, and we can do this both in the field for quick analysis with Trimble Access, so we can see hot spots while we're in the field and direct the shotcrete crew, using the scanning technology of the scanning total stations like the SX12. But then we can bring it into TBC and create more comprehensive analyses like inspection heat maps and visualize those in multiple ways, whether we're looking for thickness or smoothness or just general volume and area quantities for the amount of shotcrete that was applied. And we can create those in various types of reports. All right, and now one of the other very important tasks in all tunnel projects, both from a construction perspective, but also tunnels that exist, and maybe there's some ongoing construction or rehabilitation on that tunnel. One of the important things is performing monitoring. We were already just talking about monitoring a minute ago, but why is this important to tunneling? Well, there's a slightly different requirements here. As traditionally, when we're monitoring, we're looking at coordinate positions and the changes in those coordinates, or maybe the change in a distance as the total station measures, distance or angle, I should say. But with tunnels, we're really looking at movement relative to the tunnel axes, right? We're talking about station, so forward and backward along the tunnel. We're talking offset left, right, and up and down relative to that axis. And this is important because all tunnels are designed with some factor that they will, what as it sounds, converge in on themselves once they've been built, from all the strains in the structure or the ground around it. So it's very, very important for the survey team to collect all this data over time as the construction is progressing, to ensure that the tunnel is converging to standards and not too much, because then obviously we have some safety concerns. And so not only are they collecting that data, but they have to process it, create all of these reports with all of that. And these data sets can be quite large because they may be collecting once, twice, 3 times a day the same points, and doing that over many months or even years. So we can take all of that and additionally create more what I would call specific monitoring reports. We talked more about the general runs before, but now we're getting more into specific workflows like for tunneling and underground monitoring that are relative to the tunnel axes. And we can see those movements in context and as well create all of those configurable reports. So here I can see I have a tunnel and I have all of these movements. On the bottom, we can see it, the movement vectors relative to the actual tunnel shape, the tunnel design shape, and see which way is the tunnel moving, and also the levels of that movement. And we can take that and I'll quantify it in a nice report and see all of that movement. I'll just skip ahead here so you can see it. See all that movement in context of different axes of the tunnel, whether it's a more plan view, profile view, or a cross-section view, and then quantify that over time. Okay, did we have significant movement at a point or not? Excellent. Now, as we get closer to the end of the construction of a tunnel, one of the main workflows for the survey team is to as-built the final position of the tunnel. And a lot of the time, this is done with 3D laser scanning. One, because it's a more cost-effective means. It's faster to collect that large set of data, so we can go through the tunnel and perform a few scans to get a lot of cross sections, where before we'd have to go in with a total station and manually measure each ring or each cross section of data. So now we can get a very high density, high resolution of that tunnel surface, and we can bring all that data into TBC and create those reports from it. But one of the important parts of this is also sharing this data in a meaningful way with all of the stakeholders on site, whether it's the geotechnical crew who is doing analysis on the next section of tunnel that's to be constructed, and they're looking at the rock formations. Maybe they want to see the imagery or the scanning data that was collected, or maybe it's the owner operator who wants to see the current progress, and being able to share that data with what I would call a non-geospatial professional is very important. And so this is where I think Trimble Clarity, which Joe mentioned before, is very, very useful, where we can take massive amounts of 3D laser scanning data and share it with any of these professionals in a simple web browser. So I can just get a link, open it up, and here's a good example of a tunnel project. I believe this is in the Netherlands, where we have a massive data set, and I'll play the video again, a massive data set of that tunnel infrastructure, showing all of the assets, showing all of the information there. And then the stakeholders don't need necessarily a software like TBC, because we know that not all stakeholders on site are surveyor construction professionals. They might be engineers, they might be operators. They just want to see the data in context and help them make decisions. And I think that Trimble Clarity is a very useful tool. So all that data in TBC, once it's processed and ready, you can send it to Clarity and basically give somebody a URL, and they can view it in context. Excellent. And maybe I should have taken a little more time. I think we still have about 20 minutes. But I think with that, Joe and I wanted to talk about questions and next steps for all of you, and some resources as well if you want to find out more information. So my part here about. Oops. There, back.
Yeah.
Sorry guys, I'm not sure what's going on. So, all right, back here. So tunneling and more monitoring resources. Like TBC, we've got a ton of videos on YouTube pages. So we have a Trimble monitoring and a Trimble tunneling YouTube page. More on the how-to side, but also some good project examples if you want to see how others around the world are using technology for monitoring or for tunneling operations. As well, websites, of course, you can Google Trimble monitoring, or you can put monitoring.trimble.com or tunneling.trimble.com. And on the monitoring side of things, if you're more interested in how we're starting to automate more and more of the survey data collection and reporting and analysis, I urge you all to go to this link, or you can even go to the monitoring website and see it, where we have several live monitoring projects where you can go on and see the project, see how the data is being collected in real time, and just in a web browser. You don't need any software. So some great things. And of course, if you have any questions, I'll answer them as well.
Yeah, and one of the questions that we had come in was on where do you learn? So we put this section together hoping that we would spurn some interest, and at least we have with one person. So this is where you would learn tunneling and monitoring. And then taking a step back for the broader TBC product, our website is always a great place to start, trimble.com/TBC. Pretty easy to remember. But there's years and years of really great content out there. There is a TBC resources presentation. That's the second one that kind of collects everything and puts it all together into a PDF format. So it's the links to the YouTube channels, the power hours that we've done almost weekly tips here for the last several years. Everything that the team does to help promote and educate on Trimble Business Center is in that second TBC resources PDF. That is, of course, available on our website as well. So again, if you want one place to start with the website. Another piece that the team has worked on here, relatively new, and I'm really excited about this, particularly in the restrained personal environment that we're all operating in and hopefully will be emerging out of soon, is online learning for TBC. So there is a learn.trimble.com is Trimble's maybe you guessed this, learning platform. And if you sign up, it's the Trimble Business Center courses are 100% free. There is a Trimble Business Center page that has courses as well as learning plans, which are a collection of courses that will walk you through either a specific aspect of a workflow or piece everything together into a single workflow. So Cadastral, for example, is one that we're working on building out. There is field data processing, and that covers GNSS, optical, DINI, or digital level processing. And the really nice piece here is that we've also included a software simulation. So rather than having to go get some sort of a trial license and download and install TBC, if you're just, you just want to kind of see what it's all about, this software simulation allows you to run and be within TBC without having to do all of that. So really, really quick access into our world and into the TBC world for you to evaluate and check it out and learn more. It's very much guided. So like the tutorials we have, the simulations aren't to test, they're for education. And so they're really great if you're just getting started with Trimble Business Center. And that's available on the e-learning page via learn.trimble.com. The Trimble Business Center material is, again, 100% no cost. And then if you want to learn more and reach out to your local Trimble representative, I've linked in the dealer locator link there that will help you connect to our local presence wherever you may be.
Okay, Joe, I think there was a question that came in regarding license and whether you can install TBC on multiple computers with a network license. I think, can you address that question?
Absolutely. I can spend the next 16 minutes plus 4 hours addressing that question because whoever asked that question, thank you. I didn't see that, but that's been a topic of a lot of effort and detail here lately for us. So the answer to that question is yes. So there's two licensing options for Trimble Business Center. There's a perpetual model, and then we're rolling out a subscription model as well. So the perpetual side is either the USB dongle or a network license that can reside on either a physical server, a PC connected to the internet, or a virtual machine. And that those software licenses, we call them, can have multiple seats. So you could have all of your TBC licenses, multiple seats, multiple additions and modules, multiple seats, stored on one machine that is shared across your company's network. The subscription models are really nice because there's they're hosted in the cloud, and it's your Trimble identity login based, so no need to worry about passing dongles or losing or breaking dongles. On the subscription side, additional value adds of no cost subscription to Clarity, no cost subscription to Connect Business, our online data storage and viewing platform for Trimble. So many different options. Short answer, long. The answer to the question is yes. You can.
Okay, so Joe, just to clarify, if I have a subscription license and I use multiple computers for my work, I can always access that license just logging in with my Trimble ID, right?
Correct. As long as
one machine at a time.
Yes, correct.
That's great. There's another question that came in for both of you. So what type of files does TBC support? So for example, Survey Pro gives us a .survey file. Will that work in TBC, or does it have to be a Trimble.jxl file? Maybe downloading raw data files into TBC job files. Do we support the native file format that Survey Pro generates for its field record jobs projects?
Yes, absolutely. So the .survey file is supported in Trimble Business Center, just like the JXL or the .job that's coming from Trimble Access.
Okay, great.
And there's a variety of just generic formats too that somebody can import as well.
Okay.
Like CSV and so forth.
Correct. So the fact is, TBC is actually brand agnostic, right? You can bring in data from sensors made from other manufacturers seamlessly into the software and then create all the deliverables. I think those are the questions that I've seen here. But I would like to say that what a wonderful presentation from you guys. It was very captivating. It was always a pleasure to sit close to these guys because they're always bursting with so many new ideas that have come into fruition in the products. And as you can see, very captivating presentation. And some of the takeaways here is that as a professional surveyor, there's a one-stop application that you need for all your operations, and that's Trimble Business Center. It must be at the center of all that you do as a professional engineer or surveyor, because you can bring in all the data that you collect, analyze all the data, and then generate seamlessly all the outputs that you need for your customers. And I think Joe and Riley have established that. It's a product made by engineers and surveyors for engineers and surveyors. So actually the workflow is very intuitive, very easy to learn, and there's a ton of resources that I think both Joe and Riley have alluded to in their presentation that you can use to learn that. So the streamlined workflow applications came out strongly throughout the presentation. For all your basic surveying and engineering operations, as well as the ever-growing vertical focused models that they've developed to extend the capability of the software for certain specific tasks. So you've got the aerial photogrammetry model, you've got the tunneling model, and the monitoring model that you all refer to. That makes use of your existing knowledge of the software. Very important. You don't need to learn 10 different applications to be able to deliver what your customers are looking for. We want you to focus on the profession and on your customers, and less on the tools. So you got, once you learn that the software, you can leverage that knowledge to do different specialized tasks, and that's one strong point for TBC. Now, the fact that the training on the Trimble learning platform is free is also, I think, it's a major gift, I would say, that you can, at your own pace, learn the software, attend Trimble Power Hour sessions, ask questions from peers who have done similar projects that you are involved in on how they utilize TBC. And you can see our contact details are here, Joe, Riley, and myself. If you have any questions, technical or sales, feel free to reach out to us. We've got about 10 minutes to the end of the session. Gentlemen, I'd like to thank you for those brilliant presentations. If you have any questions, you can post them in the comment section. And I believe that after this live section, Joe and Riley would come back to see if there are any questions you guys post there that they can address. So on that note, if there aren't any other questions you have for the guys, Joe and Riley, is there anything you like to tell folks before we end this session?
I was going to say, Joe. So, how does somebody, if they've never used TBC before, can they get a trial somewhere?
Yes. So, reach out to your local distribution partner and tell them your interest. Introduce yourself if you haven't met them yet. One of the strengths of Trimble is our global presence through the channel, and so there are 30-day trials available, and your local Trimble geospatial distribution partner will be able to help with that.
And if you don't know who your local Trimble distributor is, you can go on to geospatial.trimble.com, and there's a nice map that shows all of the world and where you are.
Yes, thank you.
Cool. No, that's everything from me. I appreciate everyone for attending and all the questions that were asked. Like William said, if you want to chat more about TBC or tunneling or monitoring, that stuff, you can reach out to Joe and myself.
So
yes,
I think this brings us to the end of the session. And then I'd like to thank all of you for making time for this section. We look forward to seeing you all in the beautiful city of Cape Town next year. And we're having plans to do something bigger that you guys can participate in. So stay tuned and be looking out for any announcements that we make as part of the next FIG Congress in South Africa. I think it's certainly the time for Africa, right? So after that big World Cup song, I always remember Waka Waka, hey, this is the time for Africa. So you guys in Africa, you start making plans for Cape Town, and we look forward to meeting all of you there. We'll have a great TBC time in Cape Town. Thanks, guys. Bye-bye.
Good. Thanks, everyone.
Thank you, William. Thank you, everybody.
Take care.